We will continue with the Windows operating. Windows is a series of operating systems with a graphical user interface developed by Microsoft. Graphical user interface is the interface that we are interacting when we are using the operating system. Microsoft Windows supports different file systems from NTFS to FAT12. File allocation table is a file system developed by Microsoft that utilizes a table to store information about where files are stored and where file space is available and where files cannot be stored. So there need to be a hierarchical relationship in the operating system to show where the file space is available and where files cannot be stored. So the operating system needs to understand the structure of locating and writing and reading information to appropriate locations. File allocation table is a file system developed by Microsoft, and all versions of FAT use a table to store directory entries and use a linked list structure to allocate clusters to files. So there needs to be a linked list structure to allocate clusters to files, and files are allocated into clusters. FAT12 is actually the file system which was introduced in the 80s as the first version of FAT and is the file system found on floppy disks. Initially, FAT12 was developed to support 5.25-inch floppy disks, but was later used for the smaller floppy disks. And FAT16 was introduced in 1987, and it's a 16-bit file system that was developed for use with MS-DOS. And file names are limited to 18 characters, and the file extensions are 3 characters long. So when we use exe, it's just the 3 characters long file extension or DOC. But currently, as you know, we can use more letters to identify a file. FAT32 is the 32-bit version of FAT and uses smaller clusters that allows for more efficient use of storage spaces. And the operating system determines the cluster size. Here you see a file allocation table, and here we see the file name and the file size determined and the starting cluster address in a file allocation table. So the file actually is assigned to cluster 36, and it still continues to cluster 38, 39, and this is the end of file. And what this means is that this file is larger than one cluster and needs to be allocated into more clusters. And the FAT structure actually helps the cluster system to identify the next cluster through the use of links. And this is how actually a file allocation table works to actually allocate the file cluster and how the files are distributed through the use of file allocation table. And here what we are seeing is that deleted file actually, when a file is deleted, file name cannot be read. Let's say the first letter of the file name is actually deleted, and the file is actually still here, okay? But the corresponding clusters in the FAT structure is empty and allocated with 0 in it. So in the file structure, if the operating system sees that the FAT structure and the corresponding cluster is 0, then the computer can overwrite to these clusters, even if there's still available data. And how do we understand if the file is deleted? If the file name is actually has actually missing name, missing letter or number, then that's actually a deleted file. And we can also understand if the file is deleted from the FAT structure and by seeing zeros in the FAT structure. Okay. And here you're seeing an example of an unallocated clusters. We can still retrieve the information and the picture from a forensic imaging software, and actually this helps, the forensic imaging software helps us to view the picture even if even if the file is already deleted. And how do you find the file system on a drive? You actually need to right-click the volume or the partition on your computer. If it's a C drive or D drive, you just need to right-click, or you can even do it with the USB drive attached to it. When you right-click it, you can easily see that this is a USB drive, but you can also see that the file system is FAT32 when you right click and click the properties, and you will see that the information from here. NTFS is actually new technology file system, subsequently replaced FAT, and NTFS was developed by Microsoft and introduced with Windows NT. NTFS is the primary file system that has been included with Windows since the advent of Windows 2000, and Windows and subsequent Windows operating system still support FAT. But keep in mind that NTFS has changed a lot of things in the operating system, and the operating systems became more stable since the invention of the NTFS. NTFS actually supports advanced file encryption and compression. This is actually bringing more features to the operating system, and also supports a 16-bit Unicode character set for file names and folders, which has more international appeal. So it used to be that the other countries were not able to use their own set of characters in the operating systems, especially when they are dealing with actually basic data. And NTFS provides security to its file system with the introduction of access control lists. An access control list is a list of permissions associated with a file and details the user and programs granted access to file. We actually covered the cybersecurity section and talked about the permissions and access control, and this is actually similar to what we already talked in the cybersecurity section. The forensic examiner should know who has access to certain files through understanding the NTFS file system. And one of the advantages of the NTFS and Microsoft is journaling, a form of file system record keeping that records changes made to files in a journal. The journal uses track changes to files for fast and efficient restoration of files. So when a system failure or power outage occurs, the NTFS log with the file name $log file records these changes, and you can actually recover such information even after power outage occurs that you already or the system already kept the records through journaling. Whenever a change is made to a file or directory on a volume, the USN journal file is updated with a description of the change and corresponding file or directory. This is a very valuable information for the forensic examiner to show how the user actually made the change. The NTFS journal can be tremendously important for incident responders seeking to identify changes to files and directories on a value. Types of changes recorded are time of change, reason for the change, file directories, names and attributes, and directories MFT record number, which are valuable information for the investigation. In order to locate the $log file and $USN journal files, you just first need to open the Access Data FTK imager. Master file table maintains file and folder metadata in NTFS, including the file name, creation date, location size, and permissions for every file and folder, which is an important value for forensic examiners. Other file properties like compression or encryption are found in the MFT as well. The MFT also tracks when files are deleted and indicates that the space can be reallocated like in the FAT system. Every file directory on an NTFS volume has a file record in the MFT, and the default size for each of these entries is 1024 bytes. MFT entries actually can have several attributes, and MFT starts with an MFT header and also includes attribute headers and attribute content, and also there's an unused space in an MFT entry. And you can also review the MFT entry attribute types from the table right here. Windows creates the MFT as small as possible and it expands it only when more entries are needed. There's a risk that it could easily become fragmented if the space after the MFT is allocated to a file. To prevent this, Microsoft reserves part of the file system for the MFT. The MFT zone is a collection of consecutive clusters that are not used to store file or directory content unless the rest of the disk is full. So basically, there needs to be an MFT zone so that when the MFT needs expansion, then the MFT zone can be used and can grow in that direction. By default, Microsoft allocates 12.5% of the file system to the MFT. We use FTK Imager for bitstream copy of a hard drive, but we can also directly analyze the contents of the hard drive through loading the image and or the list of some of the files or the directories can also be mounted to the FTK Imager, and then you can analyze and examine the partitions, and also there's an opportunity to export the file that needs to be analyzed, and then later with freely available tools you will have opportunity to analyze various aspects of the operating system as well as using the access data FTK Imager in various examinations. So for example, you can locate the master file table by using access data. Master file table is actually located at the root directory of your operating system, and you can easily find the MFT file and then export it. And before exporting it, you can also analyze the MFT entries. Right here you see the file entry here, and there are more information as you scroll down the page. Prefetch files contain information about an application or any executable file. How many times an application has been run and when it was run can be understood by investigating the prefetch files on Windows. The purpose of the prefetch is to increase performance with the application startup process in Windows. An investigator can examine the prefetch file to determine what applications were run and when they were run, and it gives an important information for the investigation. You can actually locate the prefetch file on your Windows computer, but you need to have an appropriate privileges and access privileges to access to the prefetch file. So you cannot directly just click and open the prefetch file. When you actually click on the prefetch file, you're not going to be able to open it. And when you click the properties by right-clicking to the prefetch folder, you'll see that the folder size, the directory size is just 0 bytes. And that's not true, obviously. Just click the security tab and then click advanced to be able to provide new file permissions, especially read permissions. After you click advanced, you'll see that that only the administrator is allowed to actually open or read the file. And then in the next step, you just need to click to the change link over here and then open the next page user group window. You just need to type in everyone and then hit enter and then click OK. Here on this window, you actually need to click replace all child object permission entries with inheritable permission entries from this object and click enable and inheritance and actually apply and click OK. And when you go back to the Windows directory on your computer and then click prefetch, you'll be able to see the prefetch files on your computer easily. Prefetch files can be examined or parsed by the PECMD file, which is an application to parse the prefetch file. You can actually download this file by using the Week9's folder. I actually provided a link for you to download this file. Actually, when you start the command prompt on your computer, you just need to type in PECMD and then you'll see the instructions and a help manual on the screen. You can run the PECMD from your command prompt and you just need to type in the pecmd.exe and then -f and then the path of the file that you want to investigate. And when you hit enter, you'll see that the program will run and you'll see the processing information and you'll be able to find information about when the file was actually created and more information, how many times that the application was already run and the pathway to the application from the list below. Windows Registry is a hierarchical database that stores system configuration information. It maintains files used to control the operating system hardware and software and keeps track of the system's users. In terms of evidence, the Windows Registry can provide a wealth of information, including internet search, sites visited, passwords, and user activity. Windows Registry contains the default settings, user and system-defined settings in Windows Computer. And Registry serves as a repository, monitoring and observing the recording the activities performed by the user and the computer. The data is stored in the main folders in a tree-like structure, which is called Hive, and its subfolders are called keys and subkeys. Each component's configuration is stored called values. So these values are important for you to do a research and to analyze the default settings and gather information about the user and the system defined settings. And with this method, you can always find a lot of information that leads to the arrest of the perpetrator. You can actually find the path of the register hives by clicking the Windows directory and System32 and config folder, and then you can see the default file and SAM file and software and system file on your directory. But keep in mind that you cannot edit or copy these files in a live system. You need to use FTK Imager to copy these files. The most important registry drivers are shown on this picture. And you can also back up your registry by using the FTK imager. Remember the previous slides, you just need to right click and export the files to a target file where you would like to examine the evidence. Windows Registry can be considered as a goldmine of forensic evidence. Trojans and malware information can be found in the registries. So that's why registries are very important to examine. We can create new registries manually, or we can modify the ones that already exist. Original files that contain registry values are stored in the system directory itself. Registry files are system protected and cannot be accessed by any user unless administration access is provided. So keep in mind that you need to give a privilege to access to the register files on your system. And for the investigation purpose, the forensic investigators analyzes registry files via tools such as Registry Viewer, Rakeshot, Registry Browser, and many other tools are available. And Trojans and malware information, as I mentioned, can be found in the registries, and it's important to understand the structure of the registries. The registry is actually composed of two elements, key and values. And keys are akin to folders and are easily identified by noting the folder icon. Most keys contain subkeys or folders, and these subkeys can contain multiple subkeys. Registry information is technically called as hives. The Windows registry has 5 basic hives, each of which plays an important role, and it's important for you to practice and understand the content of the 5 basic registry hives. The first one is the HK class root, and second HK current user and local machine users and current configuration information are embedded in 5 major registry. HK class's root contains file name extension associations like .exe, which gives an opportunity to see what type of files are installed on your computers, and also contains in this hive are COM objects. The COM objects are the Microsoft Component Object Model, is a platform independent, distributed, and object-oriented system for creating binary software components that can interact. And this is a feature of Microsoft operating system. COM is actually the foundation technology for Microsoft OLE, Compounds Document, and ActiveX. And it's a very useful object, and you can find the information about the COM objects on HK classes root. HK current user is very important for the forensic examiner and examinations. It contains the user profile for the current profile that's logged into the system when viewed, and it also contains application usage information and an individual's internet activity details. This profile changes each time the user logs into the system, and a user profile includes desktop settings, network connections, printers, and personal group information can be found on the HK current user and is an important part of the forensic examination. HK current user contains the data stored in NT-user.dat, and NT-user.dat is a hive that stores information about a specific user account. And this hive can, for instance, contain information such as the browser settings and history and data related with the applications. This particular hive contains the majority of the configuration information for the software you have installed, as well as the Windows operating system itself. When you want to see installed software on a computer that you examine, you just need to access to the HKey local machine and software, and you can see the list of installed programs on the subkey. Contains information about all the registered users on a system, which is an important information for the forensic examiner. Within this Hive, there are a minimum of 3 keys, and the default contains a profile when no users are logged in. By using the registry editor on Windows, you can actually access all of these hives and keys and subkeys easily. A hive is a logical group of keys, subkeys, and values in the registry that has a set of supporting files loaded into the memory when the operating system is actually started or a user logged in. There are 2 ways to open Registry Editor in Windows 10. In the search box on the taskbar, type regedit and then select Registry Editor from the results. Or right-click Start and then select Run and type regedit in the Open and box and then select OK. So it's accessible through your Windows operating system. By using the registry editor, you can actually list the paths to the various installed applications. So you just don't have the application information, but also the paths to the original application installed on your computer. Registry information is also helpful for establishing the ownership of a USB drive. A record of when the device was last connected to a computer is also recorded in the metadata, and not all of these devices leave a signature behind indeed. But for those that do leave a signature, law enforcement can link the usage of those devices to the suspect's computer. You can actually locate the USB information from the registry by clicking HKey local machine system current controller set enum and USB by using the registry editor. And you can also find another very useful tool to retrieve all of this information easily from the nirsoft.net by downloading the USB view. And you can find many different types of USB devices, not just the thumb drive attached to the system by using the USB view, which is freely available, and you can download this file from this link. Windows operating system is a very old operating system, and many decades has passed since the first release of Windows operating system. The nature of some forensic evidence will change from one version of the Windows operating system to another version of the operating system. An investigator must understand these changes and how these changes will impact the investigation. Windows Vista is a milestone release of the Windows NT operating system developed by Microsoft. It was the direct successor of to Windows XP, which was released 5 years before, at the time being the longest time span between successive releases of Microsoft Windows desktop operating systems. Development was completed on November 8, 2006, and over the following 3 months, it was released in stages to computer hardware and software manufacturers, business customers, and retail channels. Windows operating systems have actually several features, including defragmentation, event viewer, ready boost, file metadata, volume shadow copy service, biometrics, backup and restores and restoration points. Many features are available for the users, and many of these features are also helpful for forensic examiners to investigate criminal or civil cases. Defragmentation is designed to increase data access speed by rearranging files stored on a disk to occupy contiguous storage locations, a technique called defragmentation. It is the process of eliminating amount of fragmentation in a file to make file chunks closer together and increase free space areas on a disk to increase the performance of the disk. Fragments of files are not always stored contiguously on a hard drive, but are often scattered. The defragmentation process can improve the read and write performance of the file system as the chunks are brought closer. In order to run the defragmentation on your Windows 10 PC, you just need to select the search bar on the taskbar and enter defrag and select the defragment and optimize drives. Event Viewer is another important, a very important subject of forensic investigations as well as its importance on cybersecurity. To open the Event Viewer on Windows 10, simply open Start and perform a search for Event Viewer and click the top result to launch the console. The investigator must prove that certain actions transpired, especially actions that involve the victims and perpetrators. Investigators can reconstruct events just by examining the event logs. After opening the Windows Event Viewer, click on the Windows logs and also click on the security, and then you can view the security logs from here. Windows events have several features that include event time, process ID, thread ID, and computer name, and security identifier, and many other features. You can locate the Windows event by clicking the Windows folder, System32 folder, and then Windows EVTN logs folder, and view the log information from this path. After you type in Windows Defender Firewall with the new window open, just click Turn Windows Defender Firewall on and then activate the Windows Firewall. You can access to the firewall log file through the path shown here: Windows directories, System32 log files, firewall, and P firewall log file. If you want to change this, you can also change the path and clear the not configured checkbox and type the path to the new location, or just click browse to select a file location on the Windows firewall settings. Computer devices in an enterprise environment provide an overwhelming amount of logs and information. It becomes so infeasible for human review, and further log messages come in different formats, and the format of the logs from some devices can also be custom defined. So these are very challenging for enterprises and large organizations. That's why many times we hear that the human factor was effective in not actually understanding the importance of some of the security logs. It's because of the overwhelming amount of information passing through the firewall logs. Since Vista operating system indexing in Windows is turned on by default, which is different than in previous versions. The indexing feature allows for search of numerous file types, which is an advantage. Indexing can help locate files based on their metadata text within a file, or even files between files between a file. User search can be saved and could be of value later to the investigator. So it's important to also analyze the Windows search engine's log results. Let's start with the very basics of the metadata viewing process. To view the digital metadata in Windows, right-click any file and select Properties, and this will open a window with the bare essential information such as size of the file, its location, and the date of the file it was created. Clicking the Details tab will deliver more informative results for the examiner. File metadata is an important element of the digital evidence investigation, and dates are a significant source of information for investigators. Volume shadow copy is a feature available in Windows 10, 8, 9, and that creates snapshots or shadow copies of disk volumes even when they are in use. It's implemented as a Windows service called the Volume Shadow Copy service. By using it, you can create or store shadow copies on a local disk, external hard drive, or network drive. So this gives a lot of opportunity for us to make our data still available even if we lose those data. So there are various types of shadow copies. The first one is the complete copy. This method makes a complete copy of the original volume at a given point in time. This copy is just read only. And the copy on write, this method does not copy the original volume. Instead, it makes a differential copy by copying all changes that are made to the volume after a given point in time. So this just creates the backup of the copy of in fact, the changes in a given at a given point in time. Redirect on write is a method that does not copy the original volume, and it does not make any changes to the original volume after a given point in time. Instead, just makes a differential copy by redirecting all changes to a different volume. Here you can see how you can start a volume shadow copy. You just need to create a restore point. Just need to type in create a restore point, and then you can reach the properties, system properties, and then just click the system protection, and then you can actually start your shadow copy from here. And when you click the shadow copy, create a restore point for the first time, and also you can adjust the size of your copy. Backing up and restoring critical business data can be very complex due to the following issues. The data usually needs to be backed up while the applications that produce the data are still running, and this may cause some inconsistencies. And this means that some of the data files might be open, or they might be in an inconsistent state. If the data set is large, it can be difficult to back up all of it at one time. So this is a greater challenge for the organization or enterprise to back up the data consistently. To restore the data, select the Start button, then type Control Panel in the search box next to the Start button on the taskbar, and select Control Panel from the results. And then in the next step, search Control Panel for Recovery and select Recovery, then open System Restore and click Next. Another subject for forensic examiners, computer forensics examiners, is in private browsing, which has an impact on a forensic analysis because it may cause the investigator to lose more evidence related to the suspect's online activities. Private browsing has the ability to hide potentially incriminating evidence, meaning it's important for a digital investigator to be able to analyze this data. Hyperfill as SYS is an important file and it contains a copy of the contents of RAM. And the analysis of RAM is quite an important subject for forensic examiners as you may reach out to several information that includes password data and what the suspect was actually doing at the time of you reached to the suspect or the things that were being worked by the suspect. And the Hyperfill SYS is saved to the computer's hard drive when the computer goes into the hibernate mode. So the size of this file is generally equal to the size of the computer RAMs. So it's as large as the computer's RAM size. When the computer is restarted, the contents of the Hyperfill SYS are reloaded into the RAM. This file is found actually in the root directory of the file, and the operating system also keeps an open file handle to this file, so no user, including the administrator, can read the file while the system is running that needs to be extracted from a disk dump or using specific tools like the FTK imager, which I previously mentioned. Thank you all for listening this session. Please feel free to access through the Blackboard or via email. I'll be happy to answer your questions. I understand this subject is pretty new for you, and I'll be happy to provide more information. But keep in mind that in the Blackboard I provided a few number of files for you to actually support the information given in the lecture. Thank you.